This is the European edition of Breaking Banks, the world's #1 fintech podcast and radio show. We bring you the European unicorns, startups, founders, regulators, and leaders innovating the rapidly evolving fintech scene today. A truly localized podcast with both English and local language content, with some of the world's most well-known hosts and influencers in the fintech sector globally. Join us every week as we explore what makes the European Union a phenomenal proving ground for many of the fastest growing fintech plays in the world today. Okay, let's roll.
Buongiorno a tutti. I am Paolo Sironi, your host of the Bankers Bookshelf. The Bankers Bookshelf is a unique opportunity for inspiration about banking and technology. Every month, I invite authors and researchers of the most interesting books and research papers which are finding a prominent space in the library of curious bankers and fintech entrepreneurs. There is not a single day without a new announcement about artificial intelligence, and especially generative AI. All top tech companies work on different algorithms. Banks are rushing in to understand and leverage the technology. Governments and regulators grasp with the need to ring-fence AI usage to ethical implementations. And the general public is divided between Bible-like enthusiasm or unjustified dystopian concerns. In the sequel of corporate announcements dominated by Sam Altman of OpenAI and Elon Musk, there is a common theme that is taking center stage. They claim that artificial general intelligence is here to come anytime soon. Do you believe AI can be sentient? Or at least pretend to sound alike? Or do you think this is another thematic to feed the venture capital grid? Well, today we have the opportunity to discuss with two experts in the field. They connected AI development with philosophy and entrepreneurship, scientific methods, and mathematical acumen. And they are Barry Smith and Jobst Landgrebe, who wrote a super interesting book titled Why Machines Will Never Rule the World. Here you see the book with all my annotations. Barry and Jobst, welcome to the Bankers Bookshelf.
It's good to be here.
Hello, thank you for inviting us, Paolo.
So let's start with the little introductions before we learn from you why machines will never rule the world. Barry, you are one of the most highly cited contemporary philosophers, contributing to research in ontology and covering multiple disciplines from molecular biology to intelligence analysis. How did you and Jobst meet and decided to write this book?
Good. So for the last 40 years or so, I've worked closely with various projects in the biomedical world. And so I began to do this work, which was philosophically motivated, but which was very practical in its applications in the period when the Human Genome Project was completed. At that time, there were many, many efforts to create repositories of data about genomics and proteomics, and also about diseases and drugs and so forth. And the problem was that these data were being collected in silos, and so they couldn't be combined. And I was part of the team who worked out how we can create a coherent collection of well-annotated data in such a way that this would allow people working in diseases, people working on proteins, people working on RNA, and so forth, to combine their data. And this was centered around something called the gene ontology. And I was in charge of the logic of the gene ontology, if you like. And so I became quite influential in the biomedical informatics world. And I came across an artifact which was used to enable exchange of data between different medical institutions. So between a lab, for instance, and a hospital, or between a hospital and a doctor, And this was called HL7, a health level 7. And knowing what I knew about logic and about data and about repositories of data and so forth, I realized very quickly that HL7 was very suspicious. It was, from a logical point of view, quite incoherent. And so I created a blog called HL7 Watch, which cataloged strange things in the world of HL7. And it happened that Jobst was working for HL7 at that time. And so he contacted me. He was my mole in the HL7 hierarchy, since he was quite senior in his position. And he had learned the same thing that I had learned, namely that HL7 was full of very strange artifacts. And so we got to know each other. And then more recently, Jobst contacted me about something that had arisen in his life, which was a concern to understand why AI was not living up to the hype. And he can describe how that works out in his contribution. But I have most recently been applying the same methods that I applied in the biomedical world, also in other areas, including the US government. So now I work with the Department of Defense and with the Department of Homeland Security on bringing about systems to ensure data interoperability across large organizations.
Sounds very interesting, Barry. And Jobst, we just learned that you worked in biomathematics and biopharma research, but you also have hands-on experience with artificial intelligence since the late 1990s, if I'm not mistaken. You also have entrepreneurial experience to develop linguistically trained AI to extract information from free text. That is something that a lot of banks and insurance companies are also willing and attempting to use. Tell us a bit more about yourself.
Yeah, so thank you. Basically, I studied medicine, biochemistry and mathematics, but also philosophy at the beginning, and always worked in this intersection of biology and mathematics. Though for a couple of years, I also worked as an entrepreneur. I founded an AI-based company that was doing claims management for the insurance industry and for health insurance. And in that context, I also created AI-based language processing solutions. And so basically, since 1998, I've always worked with AI technology in various contexts, but mainly biomedical and biological research. And when I was working as an entrepreneur, in around 2015, many customers asked me, why don't you make chatbots? Why don't you make, dialogue machines? And I said, because they will not be able to conduct real dialogues and because they won't be able to solve most of the problems that human beings solve when they work with language. And the customers didn't want to believe this. And then I started, writing, I want to write a paper. And then I contacted Barry and said, let's put our two expertises, me as a mathematician, and I specialist and you as a philosopher together to write our first paper, which we wrote in 2016. I think it's called Making Artificial Intelligence Meaningful Again. And then that was the beginning of this very fruitful collaboration, which has now led us to write a lot of other papers on this topic and this book, Why Machines Will Never Rule the World. And we are continuing. I think the intersection of our research is, I call it theory of science, because asking for the limitations of AI is a science theoretical question. And we also now work on the theory of physics, which is also very interesting. So which domains, how basically can you classify the systems that physics is concerned with, but also the models that physics is creating from a philosophical perspective adequately? It's a question that hasn't been resolved and on which we now are also working together now.
Very interesting. So, Jobst, you mentioned the need to leverage technology in meaningful ways. Now, the title of this book is Why Machines Will Never Rule the World. It's basically a constructive criticism about how AI is defined by many commentators today. That doesn't seem to make a lot of sense. The subtitle is Artificial Intelligence Without Fear. That means, yes, we can use technology, but only if you understand what it really is. We are not fearful about that, and we find the right field of application. Now, the core of this work is really to tackle a big debate around the capability of AI or not to become general, therefore, if you like, to become conscious or sentient. Now, let's first of all define for our audience what is artificial intelligence and what is artificial general intelligence.
So maybe the only way to do this is to start with human intelligence and then try to extrapolate from there. So animals and humans are intelligent. And that means that both of them are certain animals, but the higher animals, that they are able to find a meaningful solution that is meaningful to their own survival or reproduction or life to a novel problem that they haven't encountered before, for which they have not been trained and which they have never dealt with. And then to spontaneously find a solution to this problem. That is how Stern and Scheele have defined intelligence in the 1920s. And it's basically, if you look at the whole test, like the Hamburger Wechsler intelligence tests and other standard tests of intelligence, that's also what the IQ tests usually test. So the ability to solve problems that you haven't encountered before without having been trained in a meaningful way. And with this foundational definition of intelligence, now we could say, okay, so then artificial intelligence must be the ability also to find solutions to novel problems that have not been encountered before. And AI in the narrow sense means that this can be done for certain types of problems, and AGI would mean that this could be done for any type of problem. And basically, the AI and AGI proponents, they don't define it like this, but they have mathematical definitions of intelligence which are constructed in a way so that they can already show that they have solved it. So they define intelligence as a utility function for which there needs to be found an optimum. And of course, you can find optima for utility functions by differentiating them, right? And this is basically what they show. And then they say, hooray, we have intelligence. So it's like, saying flying means when you are in the air for a split second and you are jumping up and down and saying, I'm flying. Yeah, and this is basically what they do. So they have a very, very primitive definition of intelligence so that they can then say, we have met it, therefore we have intelligent machines. But if you confront them with the intelligence of definition by Scheele and Stern, they will, dodge it and try to say, no, that's not really intelligence. Oh, but that's what intelligence is, And so in the book, we show why you cannot teach this to a machine.
I find this very interesting. In my personal research, looking at economics theory and theory of financial markets, I define the neurobiological macro foundations being fundamental uncertainty and the replaceability of time. Now, when humans try to solve a problem for survival in a meaningful way, it means that they face fundamental uncertainty on their time irreversibility, which is life to death, which in a sense defines the intensity of consciousness of human intelligence, in particular compared to other species, which actually represents the value in financial services what needs to be resolved instead of just looking at mathematical concepts and optimization attempts, which typically fail when the data is constrained because it's very limited, so it's very local, cannot be very general. Now, Barry, with this in mind, which are, if you can recall them, the essential marks of human intelligence, and how does that intersect the problem of mathematics?
So I think it's useful here to draw a distinction between what philosophers call knowing how and knowing that. So the large language models of generative AI, ChatGPT, and so forth, they work only on the level of knowing that. That's actually somewhat flattering. They don't know anything, but they are able to work with propositional content, with sentences, for instance. And so they can work very well with problems of mathematics or with problems of geography or with problems where sentences are important for making decisions. But humans and animals have not just knowing that, they also have knowing how, which means knowing how to interpret a completely new document that you've never seen before, or knowing how to cope with a new a piece of behavior of animals that you're hunting that you've never encountered before, or knowing how to understand a human being who is making very strange claims about things that you've never encountered before. We can do that. And the reason we can do that is because we can force ourselves on the basis of our human will to grapple with new kinds of contexts. And the more we grapple, the more our knowing how becomes efficient, so that we can do things like ride bicycles or repair old vintage cars, or give solace to a dying person, do all of the very hard things which human beings have to learn to do by conscious experience in the world. Now, this knowing how is it would have to be part of general intelligence, but it's not something that you can teach a machine, because it's not based on the contents which we used to teach machines, which are basically propositions, sentences, or data.
Understood. Now, without offense to the native English speakers, and with due respect with those who were born in German language that is very precise, Italian, the language of Dante, has a difference between sapere and conoscenza. Sapere somehow is knowing that, and conoscenza is also knowing how, in a sense. But typically in English, we mix and match. I guess everybody uses knowledge as a single term.
Yeah.
If you're not precise with language, we don't get to the right concept. Now, I understand that being capable of resolving problems which are open to fundamental uncertainty, to changes in the world, requires a lot of complexity to be handled. And therefore, I read the parallel or an explanation in this book around the complexity theory and what can be effectively achieved in modeling a complexity to deal with the mathematical capabilities. Jobst, maybe you want to explain to us more of your research here.
Yes, so this answers your question about the mathematical feasibility of intelligence. So in the end, we don't know how human beings and animals achieve what Barry has now described as knowing how or knowing that. We just realize that they can do it. And I'd like to highlight that the machines that we have now, they don't have knowing that either, because they only can basically create sequences of symbols that occur frequently in the training material, right? And that's all they do. So they know nothing. They just create sequences of symbols. And this appears to solve some problems, but not at a very deep level. Anyhow, why doesn't this work? Because when humans produce language, the language is a result of the most complex single system that we have, which is the human brain. And only humans can, of course, produce this type of propositional language, which is only a small percentage of what the mind does, but it's an important part, because it enables societies and all the achievements of technology, planning, and so on. And this complexity cannot be modeled mathematically. And we know this from thermodynamics very well, that complex systems have properties, such as they are called evolutionary properties, but also force overlay, chaos, but also dissipation of energy, that they basically are driven and dissipate energy, that these properties create phenomena that are not amenable to mathematical modeling using any mathematics that we have. Neither can we use explicit mathematics like partial differential equations, nor can we use implicit mathematics, which is the type of mathematics that you achieve with machine learning. And so today, AI is often equated with machine learning. Machine learning is a way of creating equations implicitly, but these implicit equations are also only long polynomials, long equations that contain certain elements to map one type of data to another. And this mapping is achieved by parameterizing this mathematical equation. This parameterization is called training in AI, and it uses a lot of data and a lot of computational power. And the models that arise from this are very, very complex. They have billions of parameters, and because of this size they have and their huge parameter space, they can indeed map a subset of what the human mind does, but only in a very, very incomplete way and only in a repetitive way based on the past material they receive. And this has nothing to do with intelligence because intelligence is the ability to find new solutions to unseen problems without training. So by definition, that's not intelligence, but also mathematically, it cannot become intelligence because intelligence is a complex system output, and we don't know how to mathematically model complex systems. And as long as we cannot do that, we cannot create any artificial intelligence. Now, our theory is that we are never be able to model complex systems. And I can give you two simple examples. We have no mathematical model for the turbulence created by a wind blowing through snow in the wind in Cortina d'Ampezzo. We cannot model the turbulence of the snow when the wind blows through the snow. And we don't have any model for the process of a storm with thunder and rain. We don't know, we cannot create a physical model for this. So we can predict the storm with weather models, but we cannot describe with equations what's going on when the storm occurs. And so even this rather simple phenomena are impossible to model mathematically. So I think we cannot get mathematical models of how the human mind works.
Very interesting. So basically you're saying that there are, to use an expression that is contradictory in nature, simple, complex problems that cannot be resolved mathematically, figure out the high complex problems, like the problem of consciousness and intelligence. Mathematics are not there to resolve the issue. You actually mentioned that we don't know how this is resolved in human nature. There is an interesting field of research that sees some prominent authors like Federico Faggin, who was the inventor of the microchip in the 1960s, or Penrose Nobel Prize in Physics that look at quantum physics, so the process of entanglement, try to explain intuitively how that complexity maybe in nature, so not knowing yet how that works, right? So maybe a topic for another podcast, another also Carlo Rovelli works around these elements. But even when we deal with a simple problem that AI as it is can tackle, not being artificial general intelligence, but just, if you like, artificial intelligence, say machine learning or natural language programming, there is a need of enveloping that experience in a way that it does not derail. So it stays focused and tuned. And development is a concept that Luciano Floridi, who teaches ethics of technology and AI, has been discussing a lot. Now, Barry, where do you see the application of AI, and how do you believe we need to make sure that it stays ethical?
So first of all, the subtitle of our book is AI or Artificial Intelligence Without Fear. And I'm not sure that we chose the best subtitle because, of course, there are many reasons to fear AI because there are human beings who use AI for bad purposes. But we shouldn't fear the AI. We should fear AI in the hands of certain kinds of human beings. For instance, human beings who create spam using AI. And so what we have to do is to recognize that the grand scenarios that the purveyors of artificial general intelligence imagine for themselves, namely, for instance, that the computers, the machines might take over the world. These grand scenarios assume that we can create artificial general intelligence, that we can create truly intelligent machines. And I think that our book gets closest of any work along these lines to proving that there will never be artificially generally intelligent machines. It will never be achieved because that kind of complexity cannot be programmed into a computer, because computers are pieces of technology which use a rather simple kind of mathematics, which they then apply with incredibly long equations, as Jobst described, to perform clever tricks of various sorts, which can be useful in all kinds of ways, including in medical research, for instance. but they can't be generally intelligent, and therefore they can't take over the world. That's the upshot of our book, that computers are useful for a certain family of mathematically well-controlled problems. They can't want anything. They can't drive anything. They can't convince a nuclear power to give the keys to the nuclear bomb system so that they could take over the world. They are, from any human point of view, stupid and repetitive, and they will never take over the world. But of course, humans already did take over the world. And in future, humans will use AI to do things with weapons and so forth.
So I would say, by the same token, if AI cannot be artificial general intelligence, talking about AI ethics is misconfigured, is not the right, if you like, discussion, because you miss the subject of ethics. I not be general, therefore intelligent. And again, using language like this can create confusion and expectations between subject and object that are not helping people to understand, and also regulators and governments to figure out exactly what they have to address in terms of the rules of the game. Jobst, you wanted to add something?
Yeah, so AI ethics as genitivus objectivus is correct. So that because it is like nuclear fission ethics. So you can have an ethics dealing with which usage of nuclear fission is good and which is bad. The good nuclear fission usage is an atomic power plant, and the bad nuclear fission is the H-bomb, for example, right? And so in this sense, you can discuss AI also from an ethical perspective, that you say which usage of AI as a tool by humans is ethically good and which is bad. But the problem comes when you attribute to AI subjectivity. This is, of course, utter nonsense. And people who do this, they don't understand at all consciousness, the mind on the one hand, but also not computers and mathematics on the other. Also, one has to, what I didn't have the time to mention in my last contribution was that not only are the mathematical models that we can do restricted, but also only some of them can run in a computer. So there's even a further restriction on the mathematics that we can run in computers, that not all of them are Turing computable. So we have, as a first layer that prevents AI from taking over, the limitation of mathematics itself, and then as another layer, the limitation of computers, which will not be overcome by quantum computers, by the way, because quantum computers are theoretically also only Turing machines. So in the end, the limitation comes from the mathematics, and this needs to be understood.
Not sure. Let me say, by the way, talking ethics, everybody would agree that using a nuclear bomb is not ethical. However, there are precedents, unfortunately, in history where, under certain circumstances, some thought that it would have been ethical to use them. So the problem is not easily resolved. It's more complex. It requires a lot of checks and balances. Is the Turing test a good test to discuss about the intelligence of AI?
So Turing was a genius when he defined Turing computability, because it is a general theory of the limitations of computers. And Alonzo Church also did this in parallel. This is one of the most astonishing insights of mathematics of the first half of the 20th century. But the Turing test was, I think, formulated by Turing quite late in his life as a kind of half joke. I think the Turing test, as it was defined in the early 50s by him, makes no sense, because it's only a test whether a machine can pretend to be a human in a chat dialogue for over a short period of time. A real test for intelligence of a machine would be to put the machine in an open space, open world context, and have the machine cope with the open world context when it's confronted with novel situations. And to be honest, the machine would already fail in the central, with the sensation, with the sensory work that is needed to understand the surrounding. So already on the motor-sensory task, the machine would fail, because also already active perception of the world that every animal can do, every mammal can do active perception, every bird can do active perception. Already this capability cannot be modeled mathematically, and already there the machine would fail. Then it would fail on and on and on. But even with the most basic thing, which is active perception, which is basically perception where the movement and the perception interact to generate a conscious picture of what's going on in the environment. Already this is not feasible for mathematical modeling. And if you think about usage of AI, for example, in warfare, you can directly see how limited AI killing machines will be, because they don't have active perception. So AI used as an offensive weapon is of very limited use. It's very good as defensive weapon, but as an offensive weapon, AI has very limited usage on for that reason.
So, Jobst, a last little question for you and then to Barry before we close this episode. You mentioned your criticism about chatbots and their effectiveness some years ago. Now, this book was written just before OpenAI was released to the general public, and everybody got amazed by the leaping capabilities of ChatGPT and the latest releases. Now, clearly, there are now more, if you like, technical competencies and capabilities to mime human language and conversations, at least in an enveloped framework. So do you believe that some of those criticisms are surpassed yet, knowing that this will not be general intelligence?
I think that we have actually in the book already analyzed GPT and shown that it's just merely a sequential model and derives its limitations. And the evolution that happened then since 2022 has confirmed what you write in the book. Now, in the novel edition of the book, we will deal with this in more detail, but I think nothing has changed. These models don't know what they're doing. They don't understand the context. They create texts which are riddled with mistakes, and they invent pseudo-facts. They cannot be used for longer dialogues because the error rate becomes bigger and bigger. That has to do with the state space of the models that can only be trained for one question, one answer, but you cannot prepare a state space for deeper conversations, because as soon as we have a few rounds of conversation, you have a combinatorial explosion of possible answers. Very soon, after 3 rounds, you have more possibilities than stars in the universe. Then you can't train such a state space, and then the models will always fail. So that's also why we see almost no commercial usage of them, because for serious tasks, they are used as they are expensive toys.
So basically, in essence, it's just about how much you envelop it and you narrow that space to make usage of it, but the more you broaden it and open it, the more it derails.
Yes.
Barry, the last question and then one consideration on philosophy I want to add. What about the future of work? We understand the limitations of AI, but we also see that there are capabilities of automating one way or another some of the human activities. Is that concern misplaced?
So the experience so far is that because ChatGPT and similar large language models so often make mistakes, that they have to be checked. The output of the generative AI systems has to be checked by human beings. So in many areas where people thought they could save on the numbers of people they have to employ, they actually have to employ just the same numbers of people because a check is needed and only a human being can make that check. There are obviously areas where the ChatGPT kind of approach will indeed create the opportunity for companies to employ fewer people, but it won't be as radical as people suppose.
Very good. Now, you are a philosopher, essentially, and you may be exposed to the work of Emanuele Severino. I know that he published primarily in Italian, not in English, so I'm not sure if you could read all of his content. There is an interesting publication in English. There is a translation of a seminar that was hosted in Milano, in which Severino was talking to Penrose. The title is Artificial Intelligence versus Natural Intelligence, which is also very interesting. And I'm mentioning this one, Barry, because machines will never rule the world. However, Emanuele Severino may argue that techniques rule the world, and sometimes machines are instrumental for techniques basically to become powerful, which always requires therefore oversight, but oversight is good only if you understand exactly what we're talking about. That's why I invite all in our audience to go on Amazon, but I believe it can be found everywhere in the world. Buy and read Why Machines Will Never Rule the World, Artificial Intelligence without fear. So having said that, I thank you for the opportunity you granted us to learn from your interesting perspective, your experience, and to deep dive into some of the elements of your book. A lot of topics we could not discuss, but everybody can find them inside this a piece of literature. And I think that reading your work, we can all stay AI positive, but not AI sentient, avoiding core misunderstanding about what AI really is and can do. So all stay tuned for more, as more episodes and research discussions are coming. But now it is clear to all of us that the Bankers Bookshelf is an incredible opportunity to make an epistemological journey all together. We get inspired by authors like Barry Smith and Jobst Landgrebe of the most interesting books, papers, and publications which are finding the prominent space in the library of curious bankers and fintech entrepreneurs. With that, we can make better informed business decisions. Arrivederci a tutti and enjoy the Bankers Bookshelf jingle.
Thanks for listening to Breaking Banks Europe, a Provoke Media podcast in cooperation with FinTech Stage. Don't forget to tweet us out, shout out, or post to the team at Breaking Banks EU on Twitter. If there's something or someone you'd like to hear on our cast, let us know. See you next week on Breaking Banks Europe.